In Chapter 6, we learned about differences in pressure and how wind is formed. Now we're going to look at the different types of wind patterns that happen across the world. In this video, we're going to cover the scales of circulation. We'll start off with a very small scale. This is called the microscale. With the microscale, we're talking about something very small on the order of, 2 meters or so, very small scale. A good example of this would be something like a dust devil, or if you've ever walked around and seen a number of leaves that start to circle around, that would be a good example of a microscale. Mesoscale, you're talking about the order of miles or kilometers. A good example of a mesoscale event would be the sea breeze. The sea breeze is an event that happens from the ocean into just onto land, about the size of the circulation pattern is about the size of either a city or maybe even a county. The largest scale is the macro scale. Here we're starting to get larger, the size of multiple cities or counties, size of a state or even countries or even the world. When we're talking about the size of states or countries, we're talking about the synoptic scale. And of course, the global scale, hopefully that's self-explanatory. That's a scale that covers the entire world. Now, an interesting point about all of these different scales of wind patterns or scales of meteorology is that not only is there a difference in size between events, but there's a difference in the length that an event lasts. For example, small turbulent eddies, for example, the leaves that you see swirling around on the side of the road, those would be in this category very small, definitely microscale. Those generally last seconds to minutes. But if you get a very large microscale event, say a dust devil or a small tornado, that's bounding into the mesoscale, those last minutes to hours. Sea breezes last hours to days. Hurricanes last days to weeks. And then, of course, at the very end, the top right of this figure, you have long waves in the westerlies, another event that's associated with this. Long waves, you don't need to know about long waves, but an event that occurs right along with these long waves is the jet stream, which is a global scale wind pattern, lasts days to weeks. Here's a good example of a jet stream, and you can see how global it is in nature in these figures. Let me explain them a little bit. On the right, you have a 500 millibar chart, and the colors indicate wind speed. Notice you have a channel. Let me get a different color here so you can see it a little bit better. Let's get a yellow highlighter. Nope, that didn't work either. How about purple? Here we go. That you have a wind that is following more or less this course. This is actually the jet stream. But on the left, what we're looking at is the North Pole. Notice, let me grab a laser pointer here. Here is the United States, North America. Europe is over here. Here's Asia. And so right here, we're looking at the North Pole. Now I want you to notice here, we have a wave pattern over North America that exactly matches this wave pattern that we just saw over North America. Now the point I want you to see is that notice that these wind patterns go all the way around the Earth. This is an example of a long wave, and the jet stream is at the core of it. Now, here's an important point that we need to talk about when we talk about especially microscale meteorology. We're talking about eddies. An eddy is a circulation that forms as a result of something we call wind shear. Let me explain this a little bit more. Wind shear occurs when wind has a sudden change in speed, direction, or both. So for example, take the figure at the top. You have two layers of air. One has a certain wind speed, but the layer above it has an even faster wind speed. As the two winds, which are moving at different speeds, move past each other, this layer starts to, in between the two layers of air, starts to deform and forms a bit of a wave format. Pretty soon starts to roll up into something we call an eddy or turbulence. Turbulence occurs when eddies form within the area of wind shear. So when you talk about flying on an airplane and you hit turbulence, what we mean is that we are passing a boundary between two layers of different wind speeds, either different wind speeds or different directions, or both, which causes eddies to form in between those layers, and those eddies cause turbulence.